All right, let's take a little closer look at one-sided limits. So in that last example, we talked about sneaking up on a value of x either from the left or the right, okay? And we were seeing what happens as we get closer and closer to a certain value of x. Now, if we sneak up on that value from the left, we call it a left-hand limit. And we use this little minus superscript on the value that we're sneaking up on. All right. So the way we would read this is this we want to find the limit as x approaches 2 from the left. From the left. All right. So we're looking at the limit as x approaches 2 from the left of f of x, and it may equal some limit. Now in this case we're in this graph, the graph of this function, you can see that as x approaches 2 from the left, we're approaching this lower limit, this limit L1. Okay, so that's the left-hand limit. All right, now when we approach 2 from the other side, from the right-hand side, we can approach from values that are larger than 2. I don't like that. I'll go down. All right, so. All right, in that last example, we talked about sneaking up on a value of x from either the left-hand side or the right-hand side. So let's talk a little bit about those one-sided limits, all right, where we're sneaking up either from the left or from the right of a value. Okay, so if you look at this function in this graph, we have this graph of f of x, and it's some sort of piecewise function which has a break at 2. So if we sneak up on 2 from the left, all right, if we sneak up on 2 from the left, then we approach a limit L1, right? We're not actually going to go to 2. We're just sneaking up on it. And as we get closer and closer to 2, we get our value, the value of the function gets closer and closer to L1. Okay, now that's called a left-hand limit. And the notation that we use for that is we use this limit, right, as x approaches 2, but then we have this superscript, a negative superscript. It's negative because we're approaching from the negative side of the axis, right? The negative values are to the left. So, so we're using the little negative superscript to indicate that we're approaching the value from the left. All right, so, whoops, left. So we would read this as the limit as x approaches 2 from the left of f of x is equal to L1. Okay, that's a left-hand limit because we're approaching from the negative side of the axis, which is on the left. Okay, so now if we approach 2 from the other side, right, from values that are greater than 2, right, to the right of 2, we have a right-hand limit. And we have a similar notation for that as well. We have, we write the limit as x approaches 2, and we use this little positive superscript to mean from the right. Okay, so we would read that as from the right because the positive side of the axis is on the right. So we're approaching from the positive side of the axis. Okay, so we're approaching from the right. So we would read this as the limit as x approaches 2 from the right of f of x is equal to this value L2. All right, so we can, if we're coming at it from the right, we can get closer and closer and closer to 2 from the right, and the value of the function gets closer and closer to L2. Now, we don't know. We don't know what happens at 2. It may be defined, it may not be defined, but we're just approaching from the right. Okay, and it approaches the L2 limit. All right, so we can also use this when we have infinite limits. Now, we've looked at the function 1 over x before, and we know that there's an asymptote at 0, right? Because when x is equal to 0, 1 over 0 is undefined, right? And but so we can't go to 0, but we could sneak up on 0 from either the left or the right. If you sneak up on 0 from the positive side of the axis, so we sneak up from the right, all right, then the values of 1 over x, right, put in really small positive values like 1/1 millionth, right? 1 over 1/1 millionth is a million, right? 1 over 1/1 billionth is a billion. And so we get bigger and bigger positive numbers. And so the limit as x approaches 0 from the right is positive infinity. Whereas if we approach from the negative side, so we're plugging in values of x that are really small negative numbers, right? So 0 point, or sorry, like negative 1 billionth, right? Negative 1 billionth. If we take 1 over negative 1 billionth, we get negative 1 billion. And so as we take smaller and smaller values that are closer to 0 on the negative side, then we approach negative infinity. All right. So we can use right and left-hand limits to also look at what's happening around asymptotes, like 1 over x. So let's take a look at example 3 now. Here we have a function in this graph, and we want to look at these various values. All right. So the first thing we're asked to find is just f of -2. All right. We have this piecewise function. The closed circle means that is the value of the function. The open circle means that the value at that point doesn't actually, that's not the value of the function, but we can get as close to it as we want. All right, so if I look at f of -2, you can see if I go straight up from -2, I have an open circle here, which means, okay, that's not the value. The value is the closed value here. So we have the value -2, 4. So it looks like the value of -2, the value of the function at x equals -2 is 4. Okay. All right, now we're going to look at what happens as we approach 2. Now this is not -2. This is 2 from the left. All right, remember this little negative signs means we're approaching from the left. So we're approaching from the negative side of the axis. All right. We're approaching 2 from the left. So 2 is over here now, and we are approaching from the left. All right. So what is the value? What does the value of the function approach as we approach 2 from the left? It looks like it's approaching the value 2. Okay. Now, if we approach 2 from the right, okay, so if I look at the value of the function to the right of 2, and I get closer and closer and closer to 2 without actually going there, then it looks like the value of the function is 4. All right. So what does that mean for the limit as x approaches 2? So if you remember our definition, the definition of the limit as x approaches c of f of x is equal to some value L if it approaches the same value from either side. In this case, we're not getting the same value from either side. As we approach 2 from the left, we get 2. As we approach 2 from the right, we get 4. So this limit does not exist. And you can write DNE for does not exist. Okay, so that limit does not exist because we're getting different values as we approach from the left or from the right. Okay. All right, so let's look at f of 0. What's happening at 0? All right, now we had a hole at 0, but if we look at the value of the function, it's here, this closed circle. So at 0, it's defined to be 2. All right, but if we approach from the right, so if you look at what happens, let me erase some of my arrows so it doesn't get too messy here. As I approach from the right, you know, it looks, I can get closer and closer to 0. Now, I'm not actually going there, remember? I'm just approaching it from the right. I can get closer and closer to 0 as long as I don't actually go to 0, right? So if x is 0.0000000000001, right, then my value of the value of the function is really, really small. It's getting closer and closer to 0. The same thing happens if I try to approach from the left. Right? If I try to approach from the left, it's just going to get smaller and smaller and smaller and smaller. It's going to approach 0. It's just that I can't actually go to 0. So what is the limit as x approaches 0 of f of x? Okay, now notice we have, if we approach from the right, we get 0. If we approach from the left, we get 0. So the limit as x approaches 0 is 0. Even though the value of the function, if I actually try to go to 0, it suddenly jumps to 2. But the limit as I approach 0 from either the left or the right, the limit as x approaches 0 from either the left or the right gives me the same value, so I can say that the limit as x approaches 0 is 0. All right. Well, I will meet you in the next video to talk about continuity.